Hello, I'm here a little late. I'm a bit sick today. I don't know if I'll go as long as I usually will. We'll wait till 12:35 to get started. Oh, getting allergies and I'm a little sick. It's very frustrating. If any of you go to public schools, please, please, please don't go if you're sick. I've gotten sick 4 times this year from my students. Pull up my calculator. All right, you can see it. Let's see, what year are we doing? I remember correctly, we were doing 2016. I could be wrong. Let me check. I have the recordings, so. We'll start in a minute or so. Let's see. Yeah, we did 2016 last year, and we got down to, we got number 5 done. All right. Oh. Guess I should pull up a new page. And pull up BC number 6. Oops. Oh, we have anyone viewing today? We got 1 person. This might just be me. All right. Well, let's start. This is question 6. This is BC Calc 2016, question number 6. Oh, can you guys hear my audio? Make sure you can. Oh, you probably can't. Probably sound terrible. 1 second. There, hopefully I sound better.
9h plus 2h cubed plus 1/5 h to the 5.
Wow, I'm watching
from 0 to 10, and that's going to be, okay. Bit of technical difficulties there. All right, let's start. The function f has a Taylor series around 1 that converges to f for all interval in the convergence. When they say this, it's got to be a alternating series error bound in part B, in part D. What did I write there? Alternating series error bound. Lagrange error bound works even if the Taylor series doesn't converge to the function, strangely enough. But alternating series error bound does require it. We know f of 1 is 1, so you can kind of still write out, you can kind of just start writing out the Taylor series. It's 1 minus a half x minus 1. So that's because in general it's f prime of c, x minus c to the square to the nth power over n factorial. That's the general term. So here, this is what happens when you plug in 1. And then wants the first 4 and the general. So the next one would, I guess, have to plug into the formula. When I plug in 2, I get negative 1 squared, which is a positive. N minus 1, so 1 factorial, so 1 over 2 to the 2, so plus a quarter, I believe. X minus 1 squared. And then only one more term. I guess I'll write it down here because I don't have much space. When you plug in 3, you get negative 1 to the 3, which is actually a minus. And then you get a 3 minus 1 factorial, which is a 2. Oh, but I did forget something for this second term. It should still be divided by 2 factorial, shouldn't it? Yeah, oops. I often make that mistake. Don't forget this factorial on bottom. It should be 1 over 8, I believe. X minus 1 squared. And then for 3, you get minus 2 factorial over 2 to the 3. That's 2 over 8. That's a quarter. So minus a quarter. Then you also have to divide by 6 factorial. So, or by 3 factorial, which is 6. So 1 over 24. Great. And that just keeps going. And the general term would be, well, you just plug it in. Negative 1 to the n. N minus 1 factorial, but it is going to divide off by an n factorial. I guess I'll write that out here just to be nice. It should be like, for part A, it's like the fourth term, the general term should be negative 1 to the n, n minus 1 factorial, x minus 1 to the n, over 2 to the n factorial. The n factorial comes from this guy down here. And now, by the way, c is 1. That's not clear because you're expanding about 1. These canceling, just get an n on bottom. Sorry for the cough. So you get plus a negative 1 to the n, x minus 1 to the n, over 2 to the n times n. Looks like a general term. Apologies. All right, B, the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the integral of convergence. Let's see. Yeah, I just got to plug in the endpoints. I mean, we know the, let me erase this here because we don't need it anymore. We know the interior of the interval is negative 1 to 3 because 1 is the center and 2 is the distance on either side. We just don't know about the endpoints. So we got to plug those in, and let's plug in negative 1. We get negative 1 to the n. Negative 1 minus, I'm plugging in here basically, negative 1 minus 1 negative 2 to the n over 2 to the n times n. You can break up the negative. Then you get 2 to the n. And there's a 2 to the n here, and n. And the 2 to the n's cancel. And you get the negative 1 to the n's combine. That's like negative 1 to the 2n over n, which is like negative 1 squared to the n. This is not obvious to you. This is trying to make it clear, and that's 1 to the n, which is just 1. So you're adding up 1 over n basically, and that diverges. So diverges by its harmonic. So P series is fine. All right, and then let's try 3. At 3, you get the very similar thing. You get negative 1 to the n. 3 minus 1 is 2. Now the 2 n's cancel, and you just get negative 1 to the n. And that converges. It's alternating harmonic, which converges by the alternating series test. I'm not actually going to write all that out, but I'm not going to show the alternating series test works, but I would just say it. All right, cool. So the IOC is actually, we don't include negative 1 because it diverges there, but we do include 3 in a bracket. So that should be good enough. All right, part C. The Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Sure can. Use the first three non-zero terms of the alternating series to approximate f of 1.2. The first three terms, we kind of have those written down here. It's up there. So C, you would get, just plug in 1.2. So you get 1 minus a half times 0.2. And then you get plus an eighth times 0.2 squared. All right, and you just compute that. And that's 1 minus a half times a fifth, plus an eighth times a 25th. And that's 1 minus a 40th, plus, oh my gosh, what is that? A 400th? 8 times 25? No, it's 200. Hopefully that's right. And that's 200 minus 50, no, 5, sorry, not 50. 5 plus 1 over 200. And that's 197 over 200, 196 over 200. That seems really wrong to me. And then I guess you can simplify that down just by 4, right? 196 over 4 goes in 4 times 3, 49 over 50. Yeah, that seems really wrong. Let me, I mean, not that it like has to be wrong, but just from memory, I don't think that's right. Let me just double check my work. Point 2 squared is 25th. I guess I'm locking it in. We'll see how wrong I am. All right, luckily D does not depend on it, even though it seems like it does. You just need to use the alternating series test. You can just say the error is less than or equal to the absolute value of the next term, which is the fourth term there. So 1 over 24 times 0.2 cubed. And that's 1 over 24 times 1 over 125. And what do they want? Less than, within 0.0001, the thousandth. Yeah, and this is definitely less than 1 over 10 times 1 over 100. And that equals 1,000th. So we look good to go. Let me check these answers just to make sure I didn't make any silly mistake, which I probably did, because I'm not in my A game today. One second. Oh, it did it without a it did it as a decimal. That's so weird. They did 0.905. It seems right though. What is 49 or 50? No, that's wrong. Must have made a slight mistake. Oh, you know what? Oh, wait a second. What am I doing wrong? Something went wrong there. What am I doing wrong? Let me just think for one more second. The second one is correct. Or D is correct. 2 times 5 is not 40, Riley. It is definitely 10. See, that's how bad I am today. Let me fix that. That's a 10. I'm really attracted to that 8 for some reason. And this is a 20, and this is a 181. And that doesn't simplify. Yeah, that seems right. Okay, it's very silly. They would dock me 1 point on that, so it's not the end of the world. All right. Let's just do the AB section. Yeah, let's pull it up. Oh, come on. Oh, for Pete's sake, AP Central. Be nice. Here we go. 2016. Was that first one the same? I got to check if the tests are the same. First one's identical. Second one is a bit different. So let's do the second one with calculator. Okay, this is AB 2016 problem 2. This is with calculator. I should turn on your ability to see my calculator. There you go. Okay, for t greater than 0 particle moves along the x. I should write down what this is. This is 2016. Oops, not in red. 2016 AB calc. Problem 2. It's with a calculator. All right, for t greater than 0, a particle moves along the x-axis. Of velocity is given by whatever. Just dump that into your y equals. Just always do that. Go in here, clear some things out. Make sure you're in radians mode. I happen to be in degrees mode. All right, is it speeding up or slowing down at 4? Well, what's v of 4? 2.9817. And what's u prime of 4? It's acceleration. Why am I doing that? Oh, I need to do math 8. Because speeding up is just when the accelerate, not math 9, when the acceleration and the velocity are on opposite signs. All right, -1, so they're opposite signs. So you can just say that v of 4 is positive, v prime of 4, which I guess equals a of 4, is negative. This implies particle is slowing down. Opposite signs. Find all times t when the particle changes direction. So that's when it swaps from positive to negative or vice versa. So just graph it on 0 to 3. So we set up our window, 0 to 3. Maybe -5 to 5 is better for y. I have no idea. Let's see. Man, only once? Okay, where is that? You just find where it's 0. .70746. Now, one thing you can do is just store this into some variable. We might not need it again, but it will be an x automatically, and you can make sure it's like forever stored in a by doing that. Not forever, until you overwrite it. All right, 2.707. Justification. Well, what am I doing? Calculator shows this is a justification. That velocity is changing sign. And nowhere else. We find a position at 0, we do FDC or net change theorem. We get x of 0, or let's do x of 2 because I know that one. X of 2 minus x of 0 is the integral from 0 to 2 of v of t dt. And if you rearrange that, you just get x of 0 is, I guess 4, not 4, 2. Oh, yuck, I said, funny. All right, t is 4, not x is 4. Let me fix that. And that would just be x of 4, which is 2, minus the integral. That's the net change theorem. All right, and we calculate this, and this is 2 minus math 9, 0 to 4, alpha trace y1, dx, negative 3.815. All right, part D, find the total distance traveled from 0 to 3. That's just the integral, TDT is the integral from 0 to 3 of absolute value v of d. And that on my calculator is just math 9, 0 to 3, math no abs. Oops. Well, of alpha trace y1 dx. Bada bing, bada boom. We'll get the number in a second when it stops crying. 5.301. All right, let me check those answers. Yep, that's good. All right, and now let's see where else they differ. Question 3 is a bit different. Wait, is it? No, it's not. Question 4, I think, is identical. Oh, maybe it's not. Question 4 is not identical. All right. All right. So I'm skipping 1, 3, and 1, 2, and 3 because they're identical for A, B, and B, C. All right, slope field, just plug in. When things are 0, you should get 0. Let me draw a brighter color. Plug in 1, you get 1 over negative 1, which is here. 1 over negative 2, which is like this. All right, and then you got 4 over 1, which is like this. And, oops, I meant 1 over 1, which is like, oops, I can't see my cursor because it's so bright. That, and then 4 over 1, which is like this. All right, that's the slope field. Okay, let B be the particular solution. Its initial condition f of 2 is 3. Write an equation for the tangent line. Anytime you see tangent lines, just ask what f of 2 is and what f prime of 2 is. Not always 2, right? But that's the problem. That's the point they give. F prime of 2 is 3, f prime of 2. The f of 2 is 3, f prime of 2. Well, that's going to be, I mean, this is dy dx, right? That's going to be 3 squared over 1. This is 9. That seems completely wrong. Because I'm not over 1. Yeah, over 1. Wait. You're right. It seems wrong. I guess I should stop doing that because I just did it kind of based on memory, but come on, brain, think today. F of 2 is 3, plug in 3, 9 over 2 minus 1. Yeah, it's 9. Okay, and that just tells you the tangent line has to be L of x is 9 times x minus 3 plus 9. So x minus, oh my gosh, x minus 2 plus 3. Jeez, McCrees. All right, and they want you to approximate 2.1, so you just do L of 2.1. This is supposed to be approximately f 2.1. And that's 9 times 0.1 plus 3. That's 3.9. All right, find the particular solution. Okay, let me write it out again. dy dx is y squared over x minus 1. I divide. X to the negative 1, x minus 1. Integrate both sides. You get, it's not a natural log on the left, even though it looks like it. It's just negative 1 over y. And this one on the right is a natural log. Natural log x plus x minus 1, I mean. Plus c, of course. We'll just solve for y. Y is negative 1 over ln x minus 1 plus c. Yep, looks fine. And then you just plug in 2, 3 to find c. That's just saying this is negative 1 over c, because ln of 1 is 0, so c is a negative third. So it looks like instead, y is negative 1 over ln of x minus 1 minus a third. And you could be nicer with that if you want to. I'll leave it as is. All right, let me check if those answers are correct. Yep, looks good. All right. Oh. Oh, 2 more. I can make it. Wait, is number 5 identical? Oh, number 5 is identical. That's cool. Oh, awesome. Only 1 more. Sweet. My lucky day. Oh, a table problem. My favorite. Excuse me. So k is f of g of x on the tangent line. So again, I want k of 3, which is just f of g of 3. G of 3 is 6 from the table, and f of 6 is 4. Cool. And k prime of 3, well, that's just like f circle g prime of 3. And chain rule says that's f of so f prime of g of 3 times g prime of 3. I don't know your formal chain rule. And g of 3 we know is 6. And g prime of 3 is 2. And f prime of 6 is 5. So 10. So we have a slope and a point. And now we can just say L of x is 10 times x minus our initial or our expansion point 3, and then plus 4. Cool, that's our answer for A. Oops, I just completely boxed it, not including the L. All right, B, we want to find a quotient rule thing. All right, that's not fun. We know h prime of x, h prime of 1, I guess we can just do immediately. That's low d high, f of 1, g prime of 1, minus high d low, minus g of 1, f prime of 1. All over low squares, f of 1 squared. You just plug in. It's not very fun. F of 1 is negative 6. G prime of negative 1 is, g prime of 1 is 8. G of 1 is 2. And f prime of 1 is 3. And then f of 1, we already knew, was negative 6. So 36. And that's negative 48 minus 6 over 36. You can divide it by 6, and that's negative 8 minus 1 over 9. Nope, over 6, I mean, and that's negative 9 over 6. Sorry, over 6, and that's negative 9 over 6, and that is, divide top and bottom by 3, negative 3 over 2. Cool, that's my answer for B. Just plug and chug. C, evaluate that double derivative. Okay, well, I can use FTC to realize that's just f prime of, oh, I gotta find an antiderivative. Okay, that's kind of annoying. What do you think? No, I'm just kidding. I gotta blow my nose. I know how to do it. So you need to find an antiderivative, or I guess I actually want to u sub it. That's probably easiest. So you do u is 2x du is x d, oh my gosh, 2 dx. That'll turn this into, you'll pick up a half, you'll change the bounds to 2 to 6, and f double prime of u du, and that'll just be 1/2 times f prime of u from 2 to 6, and that'll just be a half times what's f prime of 6, well, write that in, f prime of 6 minus f prime of 2, and that's going to be 5 and negative 2. That's 7/2. All right, let's check my answers. Seven, yep, that's right. All right, cool. I guess I should explain this one a little more because it's a bit confusing. How did I know to u sub? Well, I mean, otherwise you have to find an antiderivative of f prime of 2x, f double prime of 2x. That's a little annoying. Easier to just, I mean, you could, but really easier just to use sub here. Change the bounds, do what you're supposed to do, you know. Generally, they're getting you, if you're struggling with number 6, they're getting you on not knowing the rules formally. You know how to do them by muscle memory with specific functions, but when they tell you here's f, g, and h, values of the table, it's kind of hard to remember where things go symbolically. And that's a simple issue that takes time to get over. All right, I guess I'll stop there. Well, thanks for anybody who popped in. I guess I'll check chat one last time. Nope. All right, have a good one. Anybody's watching. See you later.